So question 8, working with vectors, it says given the polar coordinates, find the rectangular coordinates. So notice how in this question, we know the magnitude or the radius, if you will, and the theta is 35 degrees. Now, if we look at our graphs, I actually pulled out a polar graph, if you will. So our radius is 5. So we have 1, 2, 3, 4, 5. So radius would be about here. And then since there's 1, 2, 3, 4, 5, 6 tick marks here, we know if I divide 90 by 6, that gives me each one of these is going to be 15-degree rotation. So 15, 30, 35 would be about here. So our vector kind of goes from the origin out to this spot here. That would be the location of our vector. So that would be a magnitude of 5 and a 35-degree rotation. So that would be the length and direction of our vector. Now, what they want to do is they want to convert this from polar back to rectangular. So we're going to try to convert this over here to our rectangular system. This is our x-axis and this is our y-axis. So what we need to figure out is, well, you know, what's our vertical and what's our horizontal? So notice that the horizontal is actually the x-coordinate and the vertical is our y-coordinate. And notice that theta is our angle. So what I kind of pick up on is, if I talk about SOHCAHTOA, you know, the other thing we have is what's called the radius r in this problem. Notice that the the cosine of an angle would be the adjacent, which is x, over the radius. So if I do a little bit of cross multiplying, we would say 1 times x is x. X is going to equal r cosine of theta. We also know that the sine of an angle is equal to the opposite over the hypotenuse, which in this case would be y over r. So if we do a little bit of cross multiplying, we'd have 1 times y would be y, so y would equal r sine of theta. So we actually have two formulas that we can use to find the x-coordinate and the y-coordinate. So the x-coordinate, all we need to know is the r, which is the radius, or 5, also called the magnitude. So 5 times the cosine of the angle, and the angle was 35 degrees. So if I put that into my calculator, it'll tell me my x direction. So 5 times the cosine of 35 degrees, and notice that my calculator is already in degree mode. So it's going to give me, let's see if it says round to certain place value. So nearest hundredth. So x would be 4.95. So that would be actually 4.10. So to find the y coordinate, we would go r sine of theta. So that's going to be 5 times the sine of 35 degrees. So we can use a little bit of trig manipulation here to get that. So if I do 5 times the sine of 35 degrees, that's going to give me my y coordinate of 2.86 or 2.87. So y is going to be like 2.87. So basically, if I come over here and try to create an x and y axis, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4. So I'm trying to make these tick marks the same spacing as over here. That's not quite perfect, but so if we go over 4.1, 1, 2, 3, 4.1 would be about here. And then if I go up 2.87, 1, 2, close to 3, 2.87. So if I make my point about here and then sketch that out, that would be the rectangular coordinates of that vector. So notice how back over here, this was our vector. So notice that we really kind of mirror the same vector just in two different uh, systems. One is what's called rectangular, and one's what's called polar. So in rectangular, what I needed was the 4.10 and the 2.87. Meanwhile, over here, we needed the radius, which said was 5, and we rotated it at 35 degrees and got to the same position. So the head of the vector is in the same spot using two different things. Now, on your calculator, you can go to the angle mode and notice that number 7 and 8, notice how this is polar to rectangular, polar to rectangular. So notice that number 7 gives us the x coordinate and number 8 gives us our y coordinate. So if I choose number 7, what I can do in here is put the magnitude, which is the 5, comma, and then the angle of 35 degrees. So if I put the polar coordinates in there, notice how it does give me the 4.097, which we 0.095, which turned into 4.10. That gave us the same thing. If I go back to the angle and choose number 8, that'll find the y coordinate. So polar to rectangular, but it'll find the y coordinate. So if I put the polar coordinates in the 5, the comma, the 35 degrees, it'll actually do the formula for us and give us then this 2.86 or 2.87. So that'll give us our x and y values in rectangular coordinates. So you can use these two formulas. X equals, the x coordinate would be defined by r times the cosine of theta, and the y coordinate could be defined by y equals r sine theta. Or we also can use our calculator to determine, to convert between polar to rectangular.